he will talk to us about low-cost silver-coated copper paste for heterojunction solar. Marwan, the floor is yours.
Thanks a lot for the introduction. Can you please allow the other account so I can share the slides?
Yeah.
Yep. Okay, so here we go. I'll start with the slides here. So I'll be talking mainly about low-cost AG-coated copper based for heterojunction solar cells. And I would like to start with the motivation for everybody here. So this is a slide that copied from presentation done by QCell at BVSec 30 in Korea. And they could realize already 23.7% in a mass production environment in their pilot line in Germany with an average of 23.56. So that is really close to the current heterojunction solar cells, except of course for the voltage. And all those cells are mainly in using quantum technology, which is a improved PERC solar cells, and therefore can enjoy low consumption of silver, can enjoy the big size of wafers, p-type, low cost, and all other aspects that heterojunction is not. So I think we need to work more hard on improving the efficiency of heterojunction and also reducing the costs, and especially cost of metallization. And as you can see also in these slides, also the target is approaching the efficiency of to reach 24. So what is buying 24 is actually either passivated contact or heterojunction, and after that a tandem solar cells. So silver consumption in heterojunction is one of the problems, not the least problem, but it's just like the consumption of silver is almost double of or more than double of current PERC solar cells. And as you can see here in the report from International Roadmap for Technology Roadmap for BV, you could see that in 2020, we're still around 200 milligrams per cell. And that is mainly the heavy metallization at the back of the cell, which in this presentation, I would like to offer another substitute for that using a copper based or silver coated copper based. So Toyo Aluminium started with producing this silver, or like research on this silver, mainly to develop fingers, screen printed fingers, and also develop a solution for soldering, so a low temperature soldering, solderable based, which is here THA B08, which was our first good solderable based. And then we improve it a little bit. And today I will be mainly talking about THAF08C4, which is our copper based. So the early we started working with multiple groups around the world in research, so to develop our based. And one of the best ones that done by Isaac Fraunhofer, and we showcased these modules in SNCC 2019, where we could get like 327 watt out of 60 cells using soldering, normal soldering technique, using our bastes, the finger bastes and the bus bar bastes. So this is a little bit of the detail of the booster that we showed that time at our booth in the exhibition in SNCC. And the the thing to highlight in that work was our soldering here, and you could see that the interface between our bus bars and the ribbons were really beautiful, and very good adhesion were realized using our soldering based. So while just developing a silver base itself, we will have a lot of competitors, especially in Japan. Multiple companies are producing silver, so we will not be like on any advantage. So we are really targeting how to reduce the cost of metallization by using our technology in Toyo aluminum. So Toyo aluminum is, yes, the name is aluminum, but we do aluminum, and we think also beyond aluminum. So we have developed a technology that allows plating of silver, gold, nickel, and tin on various powder metal materials. So we use our facilities to do this coating, so we can have a very good plating of particles in our like in-house in our company. So this is a cross section here for a particle that you can see that how uniform is the coat, and also for flakes that we could really coat them with multiple materials and use also multiple cores. So what is different from Toyo and others? We use a dispersed process during the plating itself, and therefore that we could really separate the particles very well and coat them uniformly. And also we can do a nanoside dispersed plating, and we can do also double coating, depends on the needs for or the target needs for conductivity and also reliability. So an example here that we coat silver on SiO2 particles. We coat also aluminum oxide particles and flakes with silver. So this is kind of really cheap and low cost fillers. We also coat aluminum itself with silver, and but it's of course the conductivity of aluminum if compared to others, but it's in between now. We can coat silica, so it's only the shell that could have the conductivity, and aluminum have like 60% of conductivity compared to the copper, but the copper one is the most high conductive material. And as you can see here that this is actually the copper particles and flakes that we are using in our base development. So we decided to do this copper coated with silver based, and we use this paste for the development of heterojunction solar cells. So we send it to multiple customers and also research centers, and the results here that done at CAA in France. They used 6 busbar pattern and evaluate our based, including the silver, the normal silver based, and the copper based. And as you could see here that we lose a little bit of IC, and this is due to the printing, and also of course the fill factor compromise a little bit of reduction. That is because of conductivity and also the printing of this base. But nevertheless, the reduction in the efficiency was quite small. And of course, when we talk about silver, it's already a state-of-the-art technology, but when talks about copper, then everybody will start like asking what is the reliability of such pastes. And therefore, we made 3 mini modules as reference and 3 mini modules using our copper-based. And these modules consist of 4 solar cells. And then we subject these modules to TC200. And the results were really nice, that we lose less than 1% in 2 modules, and only 1 module shows like about 2% reduction in the fill factor. and 2.4% in efficiency or in power. And that was mainly this module was mainly due to the soldering, which we confirmed by electroluminescence. So the degradation after TC 200 was less than 5%, which is a good news. And now we are doing a 400 TC to be sure more that our material is not degrading. This is electroluminescence of these many modules before and after TC200, and you could see that it's, a little degradation with the copper-based, and frankly speaking, that was really a big relieving news for me, at least. So we also test this material with series, and then they compare it to our based C4, and they're also baseline in a similar process with a few cells. And also at the series, we could see that there is also a same efficiency or a little bit improvement. And of course, it depends on the printing and processes that used in series 2. Finally, I would like to jump a little bit to another topic. Is just like, as I said, if the heterojunction itself will not really improve that fast, so we better also target tandem solar cells, which means using a silicon bottom cell, either hetero or PERC or whatever, and then a perovskite top cell. And therefore, we are developing now an option for aluminum based for the bottom cells, which is TTC20, which means that an aluminum that can contact the solar cell without allowing for passivated contact. And we also do a solderable based for perovskite for R&D purposes. And this is a data comparison of our new soldering based, low temperature soldering based, compared to the older one. And we could really go down to 150 degrees with a good contact resistivity. And we are now targeting to go even beyond toward 120 or 100 degrees with these bastes. Also, the base shows a very good contact resistance with the fingers that we printed. So finally, to conclude, and of course, the time was a little bit short for my presentation. So just to give you a conclude, we used our original plating technique to produce silver-coated copper particles, and we used that copper particles in a paste and could confirm its usability to maintain or give the same efficiency, at least if used at the back of the heterojunction solar cell. And we are quite sure about its reliability now after TC200. And thanks for listening.
Thanks, Marwan. That was concise and to the point. So that means that's very nice. So we're still running a little bit behind, but we have about almost 40 minutes still for the final